gateway project, I'm going to open up the app settings development JSON file. And let's start by defining a respective cluster for the ticketing API project. So I'm going to copy the value of the Evently cluster, and then let's call this the Evently ticketing cluster. I need to update what is the downstream address, and this will be the Evently ticketing API, and this is the name that we assigned to the ticketing API service inside of our Docker Compose setup. Now we need to configure routing to this cluster. So let's go ahead and take the default route for the Evently cluster, and let's update this to Evently ticketing route 1. Then I need to update the cluster ID to point to the ticketing cluster. I'm going to leave the authorization policy as default, but then if I specify the catch-all wildcard, it's going to conflict with the route that I have here in the Evently route. So what I have to do is be more specific in my ticketing routes. One thing we can do is introduce a prefix for all of the routes inside of these modules, or I can be very specific and explicitly map all of the routes for this cluster, which is the approach I'm going to take. So here we need to expose the orders endpoints. So I'm going to define a path match, and then I'm also going to specify orders in the transformation. And then let's add 2 more routes. So I'm going to call this Evently ticketing route 2 and 3. They will be using the same cluster and the same authorization policy. And here I'm going to specify cards and then tickets. I also need to specify the same value in the transform section. And this is how I can configure the downstream routes for the ticketing cluster. And these are the 3 endpoints that I'm exposing in the ticketing module. And with our API gateway configured, we should be ready to start the application and test out our microservices implementation. You can see that our application is running in the background. And if I open up Docker Desktop, you will be able to see the Gateway API project, the Evently API project, as well as the Evently Ticketing API project, and they are all running and are exposed on the respective ports. If I navigate to the Swagger user interface, and let's start from the port for the Evently API project, you will be able to see the endpoints for the users, events, and attendance modules. Now if I navigate to the other port, which is 5101, and this belongs to the ticketing API, as you can see here, you will be able to see the cards, orders, and tickets endpoints. So our 2 backend services are running as expected, and our API endpoints are automatically configured for each respective service. Now let's head over into Postman. I already obtained and applied an access token, and now I want to send a request to the get cards endpoint. The URL is pointing to my API gateway on localhost 3000, and this should route the request to the Evently ticketing API service. Now let's hit send. And you will see that we land on the breakpoint in the permission service of the ticketing module. This is first going to try to fetch the value from the cache if it exists, and you will see that the value is null. So we're going to try to send the get user permission request. So I'm going to add a breakpoint below and press continue. Now you can see that we hit the breakpoint in the users module and the respective get user permissions request consumer. This is going to use the permission service defined inside of this module, and I'm noting that this is a separate application, and it's going to use the permission service to resolve the permissions and return them back to the ticketing module in the ticketing API service. And now that we have our response, we can check if this is a permission response, and it is. So we're going to set this value in the cache, and we can return the permissions, perform the authorization, and only then we are going to execute the API endpoint. So I'm going to press continue, and you can see that we get back an empty cart. Let's go ahead and send the same request again, and we're going to hit the breakpoint in the permission service, but this time we're going to find the permission response in the cache. So we don't have to reach out to the other service to get our permissions. And I think this is a very elegant way of how we can encapsulate our permissions inside of the users module and still have that decoupled from the other services in our system, where they only need to implement a respective permission service, call the users module, which is going to return back the permissions. I'm going to press continue, and we will get back the response in Postman. Now I'm going to send a request to the get orders endpoint, and this should give me back the orders for the current customer. Let's take this one for example, and then I can access the get tickets for order endpoint and specify the order ID, and I should be able to see the respective tickets for this order. You can also see I'm using a ULID for generating the ticket code, which is an interesting alternative to a GUID because it's sortable, whereas a GUID is very random. And I'm going to leave some resources under this video if you want to learn more about ULIDs. Now, if you didn't notice, we managed to call the tickets, orders, and cards route from the reverse proxy, which means our requests are being properly proxied into the Evently ticketing API service. Let's also go ahead and update the user's profile, which is going to cause us to publish an integration event. So I'm just going to return this value to whatever it was initially and send this request. It's going to succeed, and in the background this is going to process the outbox message and publish a respective integration event. And now let's head over into Jaeger and take a look at some distributed traces. If you take a look at the service dropdown, you should be able to see the Evently ticketing API. So let's take a look at what are some of the traces that we have, and I can scope them by the operation. Let's take a look at the get cards operation, and if I take a look at these traces, you can see this request here with 20 spans. It looks interesting, so let's take a look at what's going on inside. So here we have a request landing on the API gateway. Is being proxied to the ticketing API. The ticketing API is going to authenticate the current user with Keycloak, so you can see a request to Evently identity here. Then it's going to try to find the user's permission inside of the Redis cache. Because it won't be able to find them, it's going to send a get user permissions request, which is going to be received in the Evently API service. And notice that this request is being sent using RabbitMQ. So here we are querying the user's database and then returning back the response to the ticketing API. It's going to process this response and eventually it's going to set this value inside of the cache. If we take a look at the next trace for the cards endpoint, you will see that we get a cache hit because we are first able to find the user's permissions inside of the cache as well as the card inside of the second request to Redis. If we go back to our distributed traces and I find a different operation, the one I'm looking for is user profile updated integration event Evently ticketing API received. I know this is a lot, but let's take a look at this trace. Here we are publishing the user profile updated integration event from the Evently API project. And we are consuming this integration event from two different queues. We have the user profile updated integration event, Evently API, as well as the same queue for the Evently ticketing API. So you can see that we are able to publish an integration event inside of one of our services, and it's going to be consumed by one of the modules inside of the same service. In this case, this is the attendance module. And then we are consuming the same message in the ticketing API service, and we are writing into the ticketing schema in the database. Let's also head over into the RabbitMQ management dashboard and see what we have over there. So if I open up the RabbitMQ management dashboard and navigate to the queues, you will see that we have more queues configured by mass transit than we did in the previous lesson because we had only one backend service. In this case, we have two services which are sometimes consuming the same message. So we have a respective queue for the Evently API and then a respective queue for the Evently ticketing API. And you can see this applies for the other messages that we have. In the case of the get user permissions request, we're only handling this in the Evently API project, as well as the cancel event state, which is part of our cancel event saga. This is also part of the Evently API service. And this is the final implementation of the Evently system. We have an API gateway routing incoming requests to the respective modules. We have one API service hosting the events, attendance, and users modules, and another service hosting the ticketing module. All of our modules have a dedicated schema inside of the Postgres database, and they are communicating with each other using messaging over RabbitMQ. We are using Keycloak as an identity provider, and we also have Redis as a distributed cache in the system. Then we have Seek that handles structured logging, and we have OpenTelemetry and Jaeger for implementing observability and distributed tracing. And this brings us to the end of this final chapter, where we implemented extracting a module from the modular monolith and moving into a microservices architecture. I hope that you enjoyed this journey in the modular monolith architecture course and learned many new things along the way. Make sure to check out the next lesson because there are some surprises inside, and don't forget to stay awesome.